Now next topic, that is acceleration. Acceleration, that is nothing but rate of change of velocity, right? Again here we have to think about first average acceleration and then after instantaneous acceleration. Now we already discussed the concept of average and instantaneous, so easily we can represent acceleration in that context. Average acceleration. So average acceleration, that is equal to average velocity upon time interval. So average acceleration, that is average velocity delta v vector upon delta t. But delta v, that is vx I caret plus vy j caret upon delta t. Simplify this one. So delta vx upon delta t I caret, delta vy upon delta t j caret. So we can say this one is the x component of average acceleration. This is the y component of average acceleration. So we can write it as average acceleration as delta ax I caret, delta ay j caret also, or simply like this. Then instantaneous one. So here we have to take limit delta t tends to 0. So acceleration, that is limit delta t tends to 0, average velocity upon time interval. So for this equation we can write limit delta t tends to 0, delta vx by delta t I caret plus limit delta t tends to 0, delta vy by delta t j caret. So acceleration A, that is dvx by dt upon I caret. So this one is differentiation of x component with respect to time t plus dvy by dt j caret. So this is the differentiation of y component with respect to time t. So acceleration, that is nothing but differentiation of velocity with respect to time t. Clear? So we can write acceleration A, that is ax I caret plus ay j caret, where ax, that is dvx by dt, x component of acceleration, dy, that is dvy by dt, ay, that is dvy by dt, and that is y component of acceleration, and this one is the differentiation of y component of velocity with respect to time t. Clear, bachcho? Now see here, if we consider motion of the particle in a straight line, so if straight line motion is there, then direction of acceleration and direction of velocity either will be parallel or anti-parallel. If velocity is increasing one in a motion of straight line, then change in velocity and acceleration both will be in the same direction. Otherwise, when we think about the motion in a plane, then angle between velocity and acceleration, that can be any one from 0 degree to 180 degree. Remember always this particular thing. Clear बच्चों? तो ये हमने ये लिखा है. अब हमने ये दो टॉपिक जो डिस्कस किए कि इंस्टेंटेनियस वेलोसिटी एंड इंस्टेंटेनियस एक्सेलरेशन, ये दोनों में एक चीज आई कि भाई इंस्टेंटेनियस वेलोसिटी, दैट इज differentiation of r with respect to time t. Instantaneous acceleration, that is differentiation of velocity with respect to time t. So differentiation of any function with respect to any variable, ये मैथ्स का कॉन्सेप्ट है, राइट? तो ये जो डिफरेंशिएशन की हमने बात की, तो सिंपल क्वेश्चन हमारे माइंड में आता है कि सर आपने बोला कि डिफरेंशिएशन ऑफ वेलोसिटी विथ रिस्पेक्ट टू टाइम टी, लेकिन ये करना कैसे होता है, कैसे डिफरेंशिएशन होता है, राइट? तो इसके बाद का जो हमें इलस्ट्रेशन दिया है टेक्स्ट में, दैट इज बेस्ड ऑन द डिफरेंशिएशन, राइट। तो हम वो डिस्कस करेंगे उसके साथ में। अब ये डिफरेंशिएशन क्या है और कैसे होता है, राइट, तो वो भी हम देख लेंगे ताकि आपको इजीली समझ में आए।